Okay, so this one's basically just a FOIL, so we're going to do first, and then outer, inner, and last. But it has really hard numbers. So I'm going to write an extra step here where I just kind of show all the things I'm about to multiply so I have them to point at. So for our first, I'm going to go root 2 times root 2, so let me just write that out so you can see exactly what's getting multiplied. And then on the outside, we'd have plus root 2 times root 5. On the inside, we're going to have plus 5 root 5 times root 2. And then on the last, we're going to have 5 root 5 times root 5. And I wouldn't write this other than for me to point at it. Ideally, you're going root 2 times root 2. There's that property that says if I have root a times itself, root a, whatever a might be, as long as it's positive, that's always going to come out to a, because you're going to get square root of a squared, which makes a. So it's nice if you skip that step and get where you can comfortably recognize a root times itself is going to make that number underneath because you're squaring and then undoing the square with the root. So root 2 times root 2, you could write down root 4, but I find that people like either write down a plain 4 or write down a root 2 and get mixed up. So if you just realize root 2 times root 2 is 2, that's the best possible case. And that is because root 2 times root 2 would make square root 4, and square root 4 is 2. It's just less steps and less places to make an error. So here, if we have root a times root b, we just multiply the a and the b together. So square root 2 times square root 5 is going to be square root 10. Here, now this messes people up a little bit. Let me put, this is one of the reasons I wanted to write this out. I'm going to put a little invisible 1 right there, and right there, maybe right there. So what that is if we're going 5 root 5 times root 2, we're going 5 times that invisible 1 in front. We're not foiling, we're just multiplying like terms the same way that we would if we had 2x times 5x to the 4th. We would go 2 times 5 makes the 10. We'd multiply the coefficients, and then we'd multiply the variables and get x to the 5th. It's exactly what I'm doing here. I'm going 5 times 1 makes 5. And then root 5 times root 2 makes root 10. So there's no foiling happening there. We're just doing multiplying coefficients together to get the 5, and then the roots together to get the 10. And then on this last spot, we got the same idea, so that would be 5, and then, oops, I'm going to do that. 5 times 1 is root 5. Root 5 times root 5 is plain 5. And again, because that would look like a 5, a root 25. Square root 25 makes 5. And so let me just real quick go back to the start. So this is all the stuff that, again, I'm kind of visualizing as I do this. I wouldn't probably write that. I would look at this as root 2 times root 2 gets me 2. Root 2 times root 5 gets me root 10. The 5 times the 1, that's the 5. Root 5, root 2 for 10. And then 5 times root 5 would be plain 5. So ideally you get to this line without all that mess in between, but this is why that's true. And then we just have to collect like terms. And there's another invisible 1 right there. That could be a bit of a problem. So this would be 2 plus 1 root 10 plus 5 root 10s. So if I have 1 root 10 plus 5 root 10s, that's going to make 6, because that's 1 plus 5 is 6. Root 10s plus down here 25, 5 times 5, and then those are still like terms, so I'll put those together and get 27 plus 6 root 10.